Up next is welcome RockCore Technology from Taiwan. Your topic is powering next-generation defense and semiconductor equipment through advanced hardware design and proprietary FPGA IP. Welcome, Project Manager Liu Wei.
Hello, everyone. Good afternoon. I am Ken Wei, and I'm also a Christian, and I'm in RockCore. And the most important thing is I'm a Taiwanese. I'm really glad that I can represent Taiwan to get this award. So thank you. And today I want to share with you about why we do this startup. You know, I have been in semiconductor industry for over 10 years. I know that I can be a consultant, I can be a coach, but why I choose startup? Because startup is just do it. We found the bottleneck, so we want to empower, use the generation for our semiconductor industry. So the most important one is we have to accelerate and also empower our equipment to be better. So that will be make us our, not only for quality, but also our UPH will be increasing. So that is what we did, is we use FPGA to deal with that. So I think Taiwan is not only an AI island, but we are also a semiconductor island too. So what we did is we connect AI and semiconductor together. That is our ambitions, and we are also on the way to do it. But by the way, we also focus on defense because, you know, some political issues, we're islands, so we have to focus on defense. So that is what we are doing. So now let me show to you about what the bottleneck and what I see in the industry we face. So first one is GPU. Okay, I think Jason yesterday I mentioned about some GPU things, but now we just want to tell you about what our customer facing in the bottleneck is the GPU latency. It's not quite a little slow. So what they wanted is want to save the time. Time is really important. No matter how, it will be have 50 milliseconds. Everyone will think it really fast. But however, they want is 10 milliseconds or 20 milliseconds. They want to reduce lower, lower, and lower. So GPU latency is quite a little bottleneck in our industry. And second part is IP issues. You know, about now, the software in PC is easy to copy and paste. So everyone will care about, wow, it's easy to copy. We cannot take it to be really protection. So we want to find a solution to fix for that, to deal with it. And the third part is legacy friction. Now we see about our equipment, you know, in factory in Taiwan, also in Asia, we have long history for the equipment and also factory. So the machines are old, and also the talent are not focused on how to do it, make it better. So now the old machine still old. How we can make it empowered? So that is what we did. We use FPGA to do that. So next step, I will show you by a golden circle. Why, how, and what. So that can see what we do. So what RockCore do is we use hardware. It is a moving AI form from software and cloud to hardware. So how we did it? We use FPGA. FPGA is a hardware we're developing, and we use our programming the AI algorithm into this FPGA, this IC. So that can make everything quickly. So that is what we do, and we'll show you how we did it. So how we did that is our domain know-how. What we do is heterogeneous core architecture. So first you can see about the first layer. What we did, we used the hardware to write down the algorithm inside. We programmed it inside, so that can also protect it. And also what we did is hardware to do the algorithm. So it's really quickly. They don't have any time to spend any time to do that. So we can make a time from 80 milliseconds to 20 milliseconds or 10 milliseconds. So that is what our important things. And second part is SoC with FPGA integration. So FPGA is really, really fast. Everyone knows that. But how to integrate? I think in Taiwan, we are really focused on and really famous for IPC, just like Adtec. They're really familiar how to use x86. But x86 is also in CPU. So how to integrate CPU, GPU, and FPGA? That is a gap. So we are the key man to deal with that. We can integrate FPGA to let it easy to have platform to integrate and also to programming in that. And that will be easy to deal with everything. And the final thing is that we found a high precision vision. We can get the vision into our FPGA to deal with that. So all the things we provide is not only a sensor, not only a FPGA. What we provided is a total solution to deal with those customers who can deal with that. So why we did it? So you can see the comparing table. The left one is the old CPU, the software what it did. So response time, I've shown you that will be for seconds, but we are for a millisecond. So we are ultra low latency. And second part is IP security. So vulnerable software layer is what I think x86 were also like in ARM-based also face the same situation. But if we write the algorithm into our FPGA, everything keep protection perfect. So that is security we can do for customers. And last thing is industrial performance. So we can see about the high software certainty about x86. So I think everyone, I don't want to raise your hand. Your PC, your notebook have some lag, but in FPGA, we don't have it. Because FPGA is also not for low latency, but they are low power consumption. So our FPGA, the heat is also can maintainable. We don't need a lot of heat and also low power consumption. So which means that we can make everything stable, especially in semiconductor industry, they need it. That is a really important thing. So for our product, we already did for success story and reference in Japanese market. We have also tagged the market in Yoshiro Group. This is focused on photography machine. The company is Adtec. They also use our algorithm of FPGA to deal with the accelerator layer product to make it. Before, they also use CPU and also easy software to deal with that. But now they use our FPGA, which is faster and also accurate. Yeah, and the other hand, we also have a project in defense-related system. We already designed in. So just for example, you know the missiles, they can wait you for a second. So we have to need a millisecond to check in the missiles and deal with that. So that is what we did, and also we have the success story. So the component to for the ecosystem is what we did. So the domain know-how for our core value is we have an embedded high-speed image processing inside. That is also make our equipment be better. And second part, we just broadened to use like a standing environmental monitor. We use 360 with the AI FPGA inside to do the tracking whole the factory. So we are not only focused on inspection, but also we can control and monitor all factory to do really an AI factory. And in future, I think maybe 2 years later, we'll do is for digital twins. That will be can read real time and also with AI agent and can deal with everything in the factory. So that can make our semiconductor industry really, really good in all things. Quality will be increasing and also time and pH will be increasing. Both increasing can make us being really a semiconductor island. Okay, so I think this time I really appreciate for Taiwan. Yeah, because Taiwan provided us a lot of resources. So you can see we have a research institution, iTree. Our company is being off on iTree. iTree is also our talent pool, can provide us really a good talent to let us to design this FPGA. And also we have IC design companies a lot, like Novatech and also MediaTek. We are also famous on IC design. And last, we have industrial PC partner like Adtec. They provided us a really stable and really high performance PC to let us integrate this FPGA inside. So while we have the new terms, we are not only AI-PC, we are stand at the Jason's shoulders, we are AI-FPC. So next generation for us, we not only focus on FPGA, but if we have some quantity and quality, we can also focus to next generation. We can use ASIC. It will be more faster and cost will be downer. So that is also our next step for in this industry we can do, and also our roadmap. So final, this is our business model. We sell hardware sales and also IP licensing, and then we can do the smart solution in factory. So that is the total solution that we can provide it in semiconductor. So that is why we connect AI to semicon. Yeah, so as I said in the beginning, this startup is not only earning money. And we are not only consultant, and we are not only for coach. What we do is what we just did it. We just do it. We do is we want to build this foundation. We make our customers increasing their UPH, make it faster, and we use algorithm in our FPGA that can do more, so we can more precise and more secure. So we are RockCore. Thank you for your listening. Thank you.
Thank you so much, Mr. Liu, for sharing on RockCore.